Okay, now we want to deal with a topic called three forces in equilibrium. Now this is tested only for pure physics 6091. Now it's not in the combined science physics. Okay, now suppose we have a mass 400 gram suspended from a ceiling, a feet support using a string, and a force pulling horizontally. Now the force in the string, which we call tension, we let it be T, so we do not know how many Newton it is, and we also do not know the force pulling horizontally, but our objective is to find how big is this force and how big is this force. Now given that is at 30 degree. Alright, so this is the question. The object 400 gram is suspended by a string and pulled by a horizontal force F, is in equilibrium. That means it's balanced. So we want to find the tension, the force in the string, and the force F horizontally, how big the force is to balance this. Now, so we know that 400 gram, it has a non-contact force of the weight, all right, which is 0.4 kilogram times for O level we take G as 10, so that will be 4 Newton. All right, so we need to draw using scale diagram, all right, in such a way, because it's in equilibrium, we end up like that, a triangle of forces, all right, where it's a closed loop, all right, and then we try to find F and T, all right, but we need to draw to scale. Take note that this triangle is in a closed loop, all right. So force 4 Newton, I'm going to draw 8 cm, all right, hold on. Okay, I've drawn 8 cm vertically downwards. This is represented by the arrow here. So this is the weight, all right, this is the weight of the object, all right, which is 4 Newton. So I actually use ruler to measure and draw 8 centimeter. Now we do not know F, but we know that F is horizontal, so I'm going to draw a line, a working line horizontally. Now because we do not know how big is F, so the line go on and on, but we know that there's one more force T that is at 30 degrees, so I'm going to draw likewise a dotted line at 30 degrees. So of course you need to use a protractor. I've pre-measured just now. Okay, so this is at 30 degrees. Alright, so this is at 30 degrees. Right, it should look like the diagram. Now the intersection point must be the point where the F and the T meets. So this is the part that is difficult for many students. So I'm going to draw them in full line now. So now you can see that the weight, all right, the F, the pulling force, and the tension by the string, they are in a closed loop, and we say that the resultant force is 0. That's why it's in equilibrium. Now go back to the question, how big is F, how big is T? Now we'll measure from here. Okay, F is right 4 cm, so it's actually 2 Newton. Now T is 8.2 cm, so it's 4.1 Newton. All right, so it's by measurement. All right, so this is I measure 8.2 cm and I measure this 4 cm. So in short, we want to find two forces, right? This is one method. Of course the question can variation, all right. At any one time out of these four, two will be known, two will be unknown, but the concept is the same. It must be in a triangle that has a closed loop such that the resultant force is zero, and you draw to scale. All right, thank you for watching.